All right, guys, today we're talking about propositions and truth values. So again, there's not going to be much math. There's a few little simple math problems involved as we go, but for the most part, we're just dealing with definitions and analyzing words. So it's another day of English in here. But we're talking about propositions which make a claim. So they either assert or deny that something is true or false. And it has to have a complete sentence. If it doesn't have both of those, if it doesn't make a claim and have a complete sentence, it's not a proposition. So I've got a couple of examples for you here. Joan is sitting in the chair. That's a proposition because it's a complete sentence and it's claiming something. I did not take the pen. Again, it's a proposition that is denying something. Are you going to the store? It is a full sentence, a complete sentence, but it's not claiming something. It's asking a question. 3 miles south of here, that's not a sentence, and it's not making any sort of claim. 7 plus 9 equals 2. Now, that's not true, but it's still a proposition, even though it's false. It's a complete sentence, and it makes a claim. Even though the claim is false, that's bad math, obviously, but it's still a proposition, okay? Now, truth values are just, is the proposition true or false? So in this first example, we have a proposition that Amanda is the fastest runner on the team. So that's our proposition here. That's what we are claiming, that Amanda is the fastest runner on the team. Now, that's either true or false. It's got to be one or the other. And we make what's called a truth table sometimes to kind of help keep track of this. So P is my proposition. So this right here is that Amanda is the fastest. So on this table, either Amanda is the fastest or she's not. So you have a true and a false. And then on the other side, we have what's called a negation. And these don't always show up, but just to kind of teach you a little bit about what negations are, the negation of a proposition is another proposition that makes the opposite claim. So in this case, the negation of Amanda is the fastest. The negation is Amanda is not the fastest on the team. So this would be the negation of the proposition. It's just saying the opposite. Amanda is the fastest is the original. Amanda is not is our negation. So that's what this not P represents right here, that she is not the fastest. Now that's either true or false. And if you look at these two, they kind of correlate, because if she is the fastest, if this is true, then this one has to be false, because she can't be the fastest and not the fastest. It's got to be one or the other, okay? And if she is not the fastest, so when it says is fastest, if that is false, then she is not the fastest, which is the true part of it, okay? Now, sometimes, and I haven't seen this in the homework yet, but that doesn't mean it's not going to show up in the future on a test or quiz, but sometimes with the negation, you've got some definitions up here that you can copy down, but sometimes we write it as not P, or you might also see it written as this. And this symbol right here is the same thing as the word not. They represent the same thing. All right. So let's apply this just a little bit. What if we have a double negation? This is kind of like, I'm sure you've heard the term before, having a double negative. So we're going to use the same proposition. We're going to ignore this example right here for just a minute. We're going to say that we're still talking about Amanda, and we're going to say that she is the fastest. That's our proposition. And our not proposition is that she is not the fastest. So a double negation is you go one step further. We would say that she is not the fastest. And if you notice on the tables here, if she is the fastest, if that is true, then the statement she is not the fastest is false. So if this is true, if she is the fastest, then not being the fastest is false. But then when we get over to the not, if she is the fastest, then she is also not the fastest, because you're saying the same thing as this first table here. The first not negates this second not. This one cancels out that one. So those go away and you're just left with the fastest. Okay, so example 2 talks a little bit about a laboratory and a scientist who was asked about the possibility of an association among young workers at another lab getting cancer. And so this is what his quote is. This is the proposition right here. Okay, this is our P. This is our proposition. My opinion is that it's unlikely that there is no association. So his opinion is that it's unlikely that there is no association. So this unlikely term is a not term. And there not being an association, there is no association, is another not term. So those two cancel each other out. So when it says, does the scientist think that there is association, the not says that he does, that he thinks that there is an association, because those cancel each other out. Okay, so be careful of those. We also have propositions where instead of just asking, or instead of claiming one thing, there might be more than one proposition. So in this case, we're talking about two different propositions. Proposition P says that the test was hard. Proposition Q says that I got an A. So those are two different propositions. But if we combine those with the word and, if I say that the test was hard and I got an A. If I combine those with the word and, then it's what we call a conjunction. Okay, we are combining them together. Now, this statement is only true if this part is true and the second proposition is true. So on my truth table, we're going to say we've got our first proposition P. So on the test, our proposition P says that it was hard. So the test could be hard. That could be true. And my second proposition, Q, says that I got an A. So the test could be hard and you could have gotten an A. Those both could be true. But the test could be hard and maybe you didn't get an A. Maybe the first one is true, but the second one is false. Well, what if the test was easy? What if that proposition is false, but you got an A? So that one could be true. Or the proposition, the first one, the test could be easy, and that one's false. And you could have still not got an A. So they could both be false. Now, so we have our two different propositions. This is that the test was hard. This is that you got an A on the test. Now, but that's not what the claim is. We're talking about the test being hard and you getting an A. So over here, we have P and A. We called that Q. That the test was hard and you got an A. So that means they both have to be true. This is true and this is true. So that means this statement is true. But if this was true, if it was hard but you didn't get an A, then the overall statement, this big statement right here, is false because it didn't do both. If the test was not hard but you got an A, then again, this statement is false. And if the test was not hard and you did not get an A, then this whole statement is false again. So the only way this statement has a truth value of true is if they're both true. Okay. Now we've also got triple conjunctions, so let's say that we're using the test was hard, I got an A, and then let's make another statement and we'll call it R. And let's say that, what should we say? That you slept good the night before the test. So we have three propositions, and if we do a conjunction, if I combine those, and I want to say that the test was hard and I got an A, and I slept good. So we've got three things involved here, three propositions. So the first one, P, and then we have Q, and then we also have R this time. So our truth table might get a little bit more complicated. Let's see if I can scroll this down. So we have a lot of options. The test could have been hard, and I could have gotten an A, and I could have slept good. Or the test could have been hard, I could have gotten an A, but I maybe didn't sleep good. So that one might be false. Or I could have gotten, the test could have been hard, but maybe the test, I didn't get an A, but I still got a good night's sleep. Or the test could have been hard, I could have not got an A, and maybe I did not sleep good. So already we've got four different scenarios that could happen. This one could also be false. The test might have been easy. I got an A and I slept good. The test was easy. I got an A, but I did not sleep good. The test was easy. I did not get an A, but I slept good. Or the test was easy. I did not get an A, and I did not sleep good. All three of them could be false. So when you're using this truth table, over here, we have P and Q and R. So all three of them have to be true. True, true, true. So this statement would be true only if all three of those were true. The rest of these, true, true, false, doesn't match my statement. So that makes it false. True, false, true, that's false because they're not all true. So all of these are going to be false because they're not all true. That statement is false unless all of them are true. So that's called a triple conjunction. All right. So we've got a couple more types of logical statements here, or types of propositions. So another way that we combine them is with the word or. So instead of and, we might say or. For example, we might say that Ryan is short or tall. That is a proposition. Well, it's two propositions. Ryan is short or Ryan is tall. So we'll call this one proposition P and this one proposition Q. And then we can look at it the same way. We can make a truth table, but we have to be careful with this word or, because in your notes here, you might want to add that or can be inclusive, which means it's true if either of these are true, or if both of them are true. Or it can be exclusive. That means basically exclusive means it can't be both. Now we assume that or is inclusive unless it tells us otherwise. But it kind of has to be taken into context, because if I look at this question, Ryan is short or Ryan is tall. If I look at that statement, proposition, the first one, Ryan is short, that could be true, but it could also be false. Okay. And if I look at him being tall, if Ryan is short, then that means that Ryan is not tall. But if Ryan is short, that means that Ryan is tall. So when I look at the combination, if I look at combining these together, which is down here, we called this a disjunction. When we combine them with and, it's called a conjunction. When we combine them with or, we call it a disjunction. So P or Q. So if Ryan is tall, then he's not short. So that could be true. If this is false and this is true, then that statement is still true. But what happens if Ryan is tall and short? He can't be tall and short. So that's false. And if they're both false, what if Ryan is not tall and he's not short? Well, that's not a possibility either. So that one's false. So in this case, this is exclusive, because it only works when one of them is true. It doesn't work when both of them are true. That's not an option, okay? So here's another example. Kevin's insurance policy states that his house is insured for earthquake, fire, or robbery. Now, what if this was an inclusive statement? That means that it's insured if there's an earthquake, or if there's a fire, or if there's a robbery. But inclusive also means if all of those happen, it's still true, he's still insured. If it was an exclusive statement and there was an earthquake that knocks his house down, and then it catches on fire, and then someone comes in and steals all of his stuff, the insurance wouldn't cover all of them. It would only cover one. So inclusive would be a good thing for Kevin, because it would cover all of them or individually, okay? So we call that a disjunction when there's the or. We can do another truth table here. Consider the statement, airplanes can fly or cows can read. Is that statement true? Well, airplanes can fly. We'll call that the P proposition, and Q will be the cows can read. So is that statement true or not? Well, airplanes can fly. Yes, that is true. But Q, cows can read, that is false. So if I ask P or Q, is one of those true? Yes, this one is true. So the entire statement is true. Okay, it didn't say that it was inclusive or exclusive, so we can assume that it's true. All right, let's look at one more situation. Now, you might not have time to get through some of the homework tonight. If you are able to, go for it. But this is an assignment we're going to work on in class a little bit together. There's a lot of statements and definitions to keep up with. So as you're going through the homework, you're going to want to read the questions very carefully, because even going through it on my end, there was a few times I didn't read it very careful and answered something wrong just because of the way I read it wrong. Okay, so be careful of that. So this one is an if-then logic. So a statement of the form if P then Q, we call this a conditional proposition. So proposition P, what comes first is called the hypothesis, and what comes second is called the conclusion. So in this example, if I am elected, then the minimum wage will increase. This is a conditional proposition because of the word if. So this is the one that comes first. So that's our hypothesis. The minimum wage will increase. That is our conclusion. That's what comes second. Okay. And we can make a truth table for this one as well. So let's make a truth table for if P happens, then Q happens. So we'll start with P and Q. So if I am elected, that could be true, and the minimum wage could increase. Those two are true. Or I could be elected and the minimum wage, maybe it decreases, maybe it does not increase. Or I could not be elected and the minimum wage could go up. Or I could not be elected and the minimum wage could not increase. Whoops, that's not a T, that's an F. So they could both be false. Now here's where it gets a little bit funky, because if P is true, then Q is true. So that's the statement that we're trying to figure out. Is this statement true or not? Well, if P is true, then Q is true. So if they both happened, if you were elected and the minimum wage went up, that would be a true statement. But if you were elected, if that was true and minimum wage did not go up, that would obviously be false because you said it would increase. Now here's where it gets a little bit complicated. Well, what if the if statement is false? What if you were not elected? Then it doesn't matter because the if part didn't happen. So in this case, you were not elected and minimum wage went up. So this statement is still true because it says if you are elected. So when that if part is false, the whole statement stays true. So if you were not elected and minimum wage did not increase, that statement is still true because the if part didn't happen. Okay, so if and thens can be a little bit confusing because the only time they're false, the only time that statement is false is if the first part is true and the second part is false. Otherwise, the statement has a truth value of true. It's always true, okay? Let's do one more example. I know we're up to like 22 minutes, but with your just watching the video today, we'll do the homework tomorrow. So we've got time for one more example. What if 7 plus 8 equals 3, then 15 plus 11 equals 2? So this is my proposition P. This is my proposition Q. So we have P and we have Q in our truth tables. So if P is true, that's one option. Then Q could also be true, or P could be true and Q could be false, or P could be false and Q could be true, or P could be false and Q could be true. So now let's look at the if then. So if P is true, then Q is true. So if P is true, then Q is true. So that first one is true. The second one, P is true, but Q is false. So this is correct, this is not. Then the whole statement would be false. If P is false, because that's the if statement, it doesn't matter what Q is. It's true either way because this statement only says if P is true. If it's not true, then you automatically assume truth. So I know that's the word true a whole bunch here. So when we start looking at this statement, is 7 plus 8 equal to 3? Oh, that was supposed to be a false. Sorry. Is 7 plus 8 equal to 3? No, that's false. So it's going to be one of these two. Then 15 plus 11 is equal to 2. Well, that's also false. So it's this bottom one. But what that means is that this statement is still true. Even though neither piece is true, the statement is true because this is not true. So this one doesn't matter. And I know those ones are going to be the ones that confuse us, and we'll work on them in class a little bit. But if you want to give a try, homework 1B is what this is associated with. Jump on, take some time if you want to try it at home. If you don't get around to it, we're going to be working on it in class since this video ran so long. So we'll see you in class.